Hello and welcome back to my Java tutorial series. Today we'll be working on episode 3, which will cover arrays and arithmetic. You can see our final project for episode 2. And I'm just about to set up a new new Eclipse project for episode 3. Okay. Ooh, now I see. Okay, so standard package for episode 3. And then we'll again set up our main class. Okay. Just like every other time, we set up our public static void main string array args. And let's start doing this. Now, the last episode, I showed you all about the primitive data types and variables of the such. So, let's just set a quick integer value to 256. Why not? Now, this is just for comparison. Now, let's set an array of integers, which would be like this. I'm not setting it to a value yet, I'm just showing how you can declare it. There are two basic ways for this side to be declared. You can either have the brackets next to the int for an int array, or the brackets next to the variable name for the array of what you're doing. I almost always put the brackets next to the type of array it is, as opposed to the name. That way it's less confusing. Similarly, you can, if you're doing this, you can also put the brackets after args, and it'll know it's a string array. But, you know, I always do that. Okay, now, like there are several ways to declare an array, there are also several ways to set an array. So one of the ways you can say new int array, and inside the brackets you have to specify the size of the array. So if I do new int 10, that means this array of integers will be able to hold 10 integers. So you're not setting the things in the array, that's how you set the size of the array. So we can say, let me just copy this, int array 0, since in almost all programming languages, that almost every single index starts at 0. So while the size might be 10, that means the indices inside of this array are 0 through 9. So we can do the value at index 0 will equal int 1. Hopefully. Oh, I need to put this over here and make that static. Yeah, need to make all those static. I think next episode I'll explain the static stuff. But either way, so we can set int array 1, then int array 1 9 will equal random number without the t. But if we happen to say int array 1 10, notice we haven't allocated the index of 10. So if we try to set this to a number, it might give us an error, it might not. But if we do try to print this out, let's just do int array 0. Then we can copy and paste that thrice. Do 9, then try to do 10. We should get an error. I'm hoping. Don't hear me say that often, but okay, see? There's an error, array index out of bounds exception. We tried to use 10 here, and this array is not outfitted to have 10 spots. If you realize if we change this to 11, now it covers 0 through 10 spots. We can try it again, and it should work. Now, if we try to print out something that we haven't set, it should print out 0, because whenever you don't declare an integer or any other of the, like a float or a double or a short or a byte or a long, their default value is 0. So if you don't declare them, so if I just do static int int 2, I haven't declared it, I haven't set it to a literal or any other value. So if we do try to print out int 2, then it'll default to 0, and so we should get a 0 in the console. Yeah. But of course, you can make an array of any value. You know, like you can make an array of strings, which we'll do soon. But let's make another array. Well, another way to set arrays. So you can do a new int array and just give it the size of the array, or you can set the array. You would use curly brackets. As you have noticed in the structure of Java, all blocks and other methods are confined with curly brackets. So if we do this, we can set the array to 1, and each of the parts in the array are separated by a comma. And you can just set it as much as you want. So right now this has 1 through 8 is the values in it. So the indexes are 0 through 7, but the size of the array is 8. So if another thing you can do with arrays, if we do int array dot int array 2, sorry, dot length, then if we print that out, it should return 8, since there are 8 indices. There we go, 8. So those are the two ways that you may set an array. Either, you know, when you declare the array or throughout the code. So of course you aren't confined to just integer arrays. You can also have a string array. We'll just set this literally, and this should work. Oh, silly me, I forgot the brackets. Haha, silly me. So we'll do hello, comma, I'm trying to, so now we have an array of strings, which are, there's 4, so the length is 4, it covers indices 0 through 3. So if we tried to print out, and in fact I don't even want to print line, I just want to do a print so it can look all fancy. We print around string array 1, index 1, because if we try to print out an array, you see every single object in Java has a certain weird number. So you see it did L Java lang string and a weird number identifier. So that's the identification code for arrays of strings. And this number might also contain the strings. But if we actually wanted to print the string, we can say print string array at 0. And if we just do the 0, 1, 2, 3, what we should get is hello world. Yep. That's exactly what we get. Okay. Now, let's see. Okay, now that we have arrays pretty much down, I think we can enter into the arithmetic portion of this. Now, we have the integer array. I think for each of the arithmetic operations, we can just reference them. So, yeah, more practice. And with the arithmetic, there are also unary operators, is what they're called. So they're basically operators that are like one character, hence unary. And a lot of these are like plus signs, like x equals int array 2 index 0 plus, I forgot to call x an integer, silly me. Silly me, in fact. So that means the indice at 0, which is 1, and the indice at 5, which has the value of 6. Wait. 0, 1, 2, 3, 4. Yeah, it's 6. So that means 1 plus 6 is 7. So x, hopefully, equals 7. So the plus sign is a unary operator, you know, fancy word. And it adds things, and also you saw in the previous episode where we covered strings, it also concatenates strings. So if we run this, hopefully we get, that's not what I was looking for. Oh, integer array 2. I was referencing the wrong array, my fault. But if we run it, we should definitely get 7. There we go. So we know math works. The next thing we can do is integer y equals, how about we can just copy this. That would make my life easy and this video shorter, more or less. So we'll do this, but instead we'll do minus. I hope you all know what subtraction is, because here it is. And we should know that 6... Crap, wait. What did I do wrong? Oh, still outprinting that. And 4, because we all should know that 6 minus 2 just happens to be 4. Next one, integer z will equal something like this. Actually, let's just stop using it. We'll do 5 times 5. We'll output z, and this should be 25. Yay, math is still working, hasn't failed us yet. Integer a. Ran out of room, unfortunately. How about 81 divided by 9? And this should be 9. Ta-da. Now, if it were something odd, like let's say we did 79 divided by 9, now a is an integer, so it won't be a floating point, so it'll get a float as a result, but since we're casting it to integer, it'll automatically make it an integer, which means normally it would be like 8.7 or 8 something, but whenever you cast a float or a double to an integer, it automatically just rounds down, and now you have an 8. But if we were to get this to a float, and we play, then it's 8, should not be 8.0. Definitely should not be 8.0, it should be 8 point blah 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 blah. At the very least, it's interesting. Well, who cares? Let's continue. We'll come back to that. So let's do integer b equals, one simple, let's do 40 modulo 2. Okay, now a lot of you might not be familiar with modulo. That is a percent sign, but we call it modulo when we're using it as a unary operator. It's also called the remainder operator. So what happens is 40 divided by 2 is 20. But this won't return 20. The division would return 20. But what the modulo does is that it returns the remainder of the operation. So instead of it, when you divide 40 by 2, it's evenly divisible by 2. So you get 20 is what the answer would be, but the remainder would be 0. So if we try to print out b right now, we'll get a 0. But if we did 41, now, if you know your simple arithmetic, you know 41, 2 does not go evenly into 41. So 41 divided by 2 would normally be 20.5. But if you were in simple elementary school math, then the teacher would say it's 20 with a remainder of 1. So that means if we run it, we'll get a remainder of 1. Now, modulo 2 is the way to determine if numbers are even or odd. Which, yeah. If you, so, once we get into conditionals and loops, which will be in maybe 2 or 3 episodes, we'll say, if 41 modulo 2 equals 0, then you'll print b is even. What's all this yellow? Maybe if we change that to 40, maybe it just like automatically detects that. Yeah, it does. Don't know why it's being that nitpicky about it, but you know, if we do, fine, if you want to be that. Let's just do b equals 41, and we'll see if b is divisible by, if b is evenly divisible by 2, we'll get b is even, and obviously it isn't. We still have this here. We'll comment that out. I'll get to comments soon. That's very easy. We can fit in this episode, right? Hopefully. I know I might be going over some of your head, but you know, if anything I can do to clearly explain this. So, obviously, 41 is odd. It's an odd number. So, but if we change 41 to 42, then it is evenly divisible by 2, and it says b is even. So, yeah. Let me explain. We'll get to simple comments, and we'll get to now, and we'll get to job ducks. Well, let's finish unary operators. Okay. Well, you can also do some simple ones. You know, you can set this to automatically, you know, this is positive 256. You can put a plus in front of it if you want to be specific. But also, if you want to make it negative, there's negative. That's simple enough, right? Okay. So then, let's get rid of that crap. Actually, no, let's keep it. That'll be easy. And we'll put this back here. And you also do, you know, more than just modulo 2. Like 25 modulo 5 is going to equal 0, because you have the remainder. 24 modulo 5 would be 1, since, wait, it'll be 4, since you'll have a remainder of 4. Okay. But besides that, so let's do something else. Let's say, okay, let's do int 1 plus plus. What happens is plus plus is a convenience method. Basically, plus plus is the same as saying int 1 equals int 1 plus 1. Which, you know, that's pretty cumbersome to type out. So if we just made it print int 1, right now we'll get 257. Yeah. Now, if we just did int 1 plus plus, it'll be still 257. Convenience method. Opposite applies for minus minus. Now we'll get 255. And there you go. One more unary operator to discuss is just for Booleans. So let's just say, well, I kind of want to keep that there. So, you know, I might just post, if anyone wants me to post the source code, so you can like look at it and not look at the video, then I'll do that. I'll more than happily do that, but I'll just wait for a request, as opposed to just doing it, because I don't want to do it unless anyone wants it. Either way, so let's say this Boolean bool equals true. Okay, so now we have something that equals true. I think if we print this out, it might print out true. It prints out true. What a miracle. I thought it would print out one of those class identifiers. But either way. But what we can do is Boolean bool2, set that to bool1, equals exclamation point bool1. So this exclamation point, basically, if you put it in front of any Boolean, anything that outputs a true or a false, it immediately gives you the opposite. So if we printed out bool2, we set bool2 to the opposite of bool1. The opposite of true is false, so it should output false. So if we set bool1 to false, bool2 is the opposite of bool1, which is false, so now it should output true. And now it's true. But with also Booleans, you don't have to set it to just the key value. You can also say Boolean equals is x greater than y. And that's just inequality. It's a comparison. So if x is greater than y, it'll be true. If x is less than or equal to y, it'll be false. And x is greater than y because 1 plus 6 equals 7. And 7 is greater than 4. And 5 minus 2 is 4. So 7 is greater than 4. We just established that. I think that is about it for this episode. Hopefully it was a fairly swift one. Thank you for joining me in learning Java again, and see you next time.